Okay, so we're going to talk about throwing an interception. And remember, this is a develop understanding task, so you may not fully understand what you're doing by the time you're done, and that's okay. You're just starting to understand. The x-intercepts of a graph of a function are very important because they are solutions to the equation f of x equals 0, or y equals 0. In past tasks, we learned how to find the x-intercepts of the function by factoring. Hello, we just did that, which works great for some functions, but not for others. In this task, we are going to work on a process to find the x-intercepts of any quadratic function that has them. We'll start by thinking about what we already know about a few specific quadratic functions, and then use what we know to generalize this to everything. Basically, right now, if your quadratic looks like the ones on your yellow paper, you can factor it and figure out where it crosses the x-axis. But lots of them don't. Lots of them don't land in nice areas. And so we have to have something that will always work. And that's what we're starting to build up to. But let's review what we do know. Let's say we had the one from number 7. So y equals, oh, I don't want to do that one. Let's say we had x squared plus 5x plus 6. Okay, we could factor that, and we could say what multiplies to make 6 and adds to make 5. Write this on your paper. That would be x plus 2 and x plus 3. And so we went from standard form to intercept form. And we call that intercept form, and you're going to want to write this down because you're going to do it yourself in a minute. Because, remember, intersect form is x minus p, x minus q, because p and q are where the graph crosses the x-axis. And remember, they're always the opposite of what's in parentheses. So we have a positive 2 and a positive 3, so it becomes negative 2 and negative 3, which means if I graphed it, 1, 2, 3, it's going to cross at negative 2 and negative 3. Guys, is it going to open up or down? Up. Thank you. Because this is a positive number. So it's going to look something like that. Now, I don't know how far down the vertex is. I don't know where this vertex is. So if you remember what we did was we found the middle. Well, what's halfway in between negative 2 and negative 3? Wouldn't that be negative 2.5? Guess what? That's my axis of symmetry. And then what we learned is if you have the x and you want the y, plug in that negative 2.5 for every x. So negative 2.5 plus 2 times negative 2.5 plus 3. And you can put that right in your calculator. Hello, turn on or not. Okay, this is not working. Okay, parenthesis, negative 2.5 plus 2 times negative 2.5 plus 3. And I get negative 0.25. So my vertex is actually about right here. If this is -1, it's about right here. So it's going to look like that. Okay, you had to do this on the last test. It's wanting us, our whole goal for this is to find these 2 points. Those points are called the solutions. Those are the x-intercepts. Okay? So that's what we know, but sometimes this doesn't work out. So we're leading up to how could we do this with a formula if this doesn't always work. So here's what we have. What can you say about the graph of this function? It is in standard form, just like the one I just gave you. I need you to graph the function with your group, and in order to do it, I need you to factor it. What multiplies to make -3 and adds to make -2. That will go right here. Then I need you to find the halfway point to find the axis of symmetry. Then I need you to plug it in. Do this with your group. See if you can graph it and answer A, B, and C. So, if you looked at it, what multiplies to make -3 and adds to make -2, that's +1 and -3, which means our P equals -1 and our Q equals 3. So it's going to cross at -1 and 3. Why I'm talking about P and Q is here's a summary of everything we learned last unit. This is intercept form, and these values are called P and Q. And it says, to find the vertex, that's this bottom number right here, this bottom point, you do P plus Q divided by 2, or that is halfway between these two. And every group I talked to saw that the halfway was 1. So that is your axis of symmetry. X equals 1. Okay? That means we got to find the middle. It says it right here. Axis of symmetry is the value of X halfway between P and Q. Now, we don't know how low this goes. Does it go here, here, like that? Okay, so we're going to plug it in into the original equation. Everywhere there was an X right here, we plugged in this 1. And if you do that, you would get -4. So my vertex is at 1, -4. This is always the same. And so down, over 1, down 1, 2, 3, 4. And I also know that it crosses the y-axis. It crosses this, not the axis right here, at -3 when x is 0. If I were to put a 0 in right here, it would give me -3. But if it's standard form, I already know it's going to cross at -3. So there's my graph. Oh, that's -1, excuse me. It's going to cross at -3. Okay, that was the end of last unit. The important part of this are these 2 values right here, because those are called the solutions. So what we have here is a summary of everything at the end of unit 2, okay? Can I turn it? All right, so now we're going to talk about, they've got intercept form here. Let's think about it. Going back and looking at that picture, what were the x-intercepts? The x-intercepts were 3 and -1. Right? It says, what are my x-intercepts? Where does it cross the x-axis at 3 and -1. Okay? How far from the x-intercept is the line of symmetry? I want you guys to think about B, C, D, and E for just a minute with your group. Do this. It says, how far away from the line of symmetry are these points? 1, 2. Right? So, 2 units away. If your line of symmetry was H, so if instead we just called this H, right? Wouldn't you, how would you find the actual x-intercepts? Okay, well, it would be H minus 2 and H plus 2, right? If this line right here was called H, then this would be H plus 2, and then this would be the value minus 2. So think about it. If H is 1, 1 plus 2 gives us the 3, and here 1 minus 2 gives us the -1. How far above the vertex are the x-intercepts? Well, let's go back here. Let's see. They are 1, 2, 3, 4. 4 units above. You guys, any questions on that? Okay, they are 4 units above. What is the value of f of x at the x-intercept? F of x just means the same thing as y. So what's the value of y at the x-intercepts? It's always 0. Okay, so I'm going to walk you through this part. Just to make it a little easier to talk about some of the features that relate to intercepts, let's name them with variables. From now on, we talk about the distance from the line of symmetry. We're going to call this D. So instead of being 2 in the last problem, we would just call it D. Okay. We will always refer to the line of symmetry as H. So this is x equals H. The distance from that line is D. So this point would be H plus D, comma 0. And this point would be H minus D, comma 0. The goal here is to generalize what we noticed. That you always go to the center and then add and subtract to get to the intercepts. Make sure that's on your paper so I can move on. Okay, so now we're going to start with vertex form. So just like here where I summarized everything from intercept form from the last unit, I have summarized everything for vertex form. Okay, it says, so let's think about another function. This function right here is in standard form, and you need to turn it into vertex form. That is completing the square. Okay, that's these steps. Make sure A is 1. Well, it is. So rewrite it with a space. Okay, I rewrote it with a space. Now you need to take half the middle number, square it, and add or subtract it to both parts, and then rewrite it. We've done this before in a quiz. Okay? Please do this now with your group. and try to answer the questions. This is the end of last unit. Right, step 1, we write it with a space. Well, that's step 2. Step 3, half the middle number squared is -3. -3 squared is 9. So I add it here and subtract it here. That's this step. Now we rewrite it. This is rewriting the quilt like we just did. So that's x minus 3 squared. It's always half of this number. And then 4 minus 9 is -5. Now it is in vertex form. So if you go up here, this is vertex form. So okay, we have x minus h squared plus k. And if you go up here, it says, oh look, our vertex is h and k. So our vertex is +3, -5. +3, -1, 2, 3, 4, 5. Yes. Because anything in parentheses, it always switches. So then the axis of symmetry, guys, always goes through the vertex. And if you look at your notes here, it says the axis of symmetry is the h value of the vertex. Oh, so it must be +3. What do you estimate the x-intercepts of the function to be? Well, I don't know, but I know that the y-intercept is going to be at 4. 1, 2, 3, 4. So if I were to draw this in, okay, that was 3 away. So this looks like it's 3 away. So I don't know, but I know that they're right here. Okay, I know it's this point and this point. Wouldn't you say that that first blue point is a little below 1? And the second point is a little, it's going to be 5 in a little bit. Right, look, a little less than 1 and a little more than 5. Any questions on that? Okay, so what do you estimate it to be? So I'm looking at D as probably 2 and a little bit, right? Remember D is from the center to the edge? So I'm thinking 2 is 2 point something, 2 and a little bit, right? Because 3 plus 2 point something would be 5 and a little bit, and 3 minus 2 something would be a little less than 1. Let me see your thumbs if you understand what I'm doing right there. I get it, I sort of get it, I have no idea what's going on. Everybody that has a thumb, vote now. That's how I got the 2 something, 2 and a little bit. Now it says, what is the value of f of x at the y-intercept? Remember, y-intercepts is going to be something x and a 0. This is 5 and a little bit, I don't know. 5 point something, comma 0. So it's going to be 0. They want you to remember that the x-intercept y is always 0. Now here's the most important part. Using the vertex form of the equation, here it is, write an equation and solve it to find the exact values of the x-intercepts. We want to know this x when y is 0. So I'm going to let y equal 0 and solve. Next class period, I'm going to give you notes on how to do this exactly. Today, you just have to follow. We want to get x by itself. So the first thing I'm going to do is add 5 to both sides. Okay. How do you get rid of a square? What's the opposite of a square? A square root, right? The square and the square root cancel out. So we want to square root both sides, and we have to add a plus or minus. We're going to add 3 to both sides, and you get this. X equals 3 plus or minus the square root of 5. Those are your answers. And then you could put them in your calculator to figure out what that really is. So, if I did 3 plus the square root of 5, oh, I get 5.2. Didn't we say it would be 5 in a little bit? Question. You put it in your calculator, you'd get those two values. Now, didn't we said it'd be 5.2, we said it would be 5 in a little bit. And 0.76, we said a little below 1. Oh, look, it worked. So my x-intercepts are 0.76 and 5.2. So this value actually right here is 5.2 comma 0, and this one is 0.76 comma 0. They would not factor, so we had to solve by taking square roots.